I know we have that slant asymptote to look at, and we're going to do it, but I want to show you one thing on your graphing calculator too. We just ran out of time. So remember, we already had this one filled in. We had factored this. We're always going to try to factor and simplify first, and we had the hole in this one, okay? This is nothing exciting. You already have all this done. We just had the line. Here's what I want to show you is how you can actually, I'm going to try not to complain about Texas Instruments, but no problems, no promises here. How you can actually see the hole on your graphing calculator if you wanted to double check it on there. Now, here's the thing. If I just type in y equals x minus 1, if I just type that in, y equals, hit graph, it's just going to give you your diagonal line here. And we know that there was the hole, remember, yesterday at -1, -2. It's not the world's best graph, but that's what it is. So here's what you have to do if you're curious or want to get your calculator to display it. And it's kind of a pain if we're going to be honest. So you're going to go to y equals, of course. I'm going to clear this out. I'm going to pull up my horizontal fraction bar, however your calculator has the function there. Now, to get it to show you the hole, to display it, you have to type in the original function before you simplify it. So I'm going to type in the x squared minus 1 over the x plus 1. Now, when I hit graph, this isn't going to be anything exciting. There's our diagonal line. Now, I know some of you, probably in the back hard to see, but do you look through that blue diagonal line? Do you see the hole anywhere? No. Okay. Why would Texas Instruments make it easy on us? Okay. So first, obviously, you can always check your table, and you see that error message there. That should be a key point that you have a hole in this graph. To actually get your calculator to show it, you have to hit zoom. Bless you. And you have to use, if you haven't used it before, you have to do zoom decimal, number 4. Now do you see the hole? Now you can see it. So if you're ever like, oh, I think there's a hole, I'm not sure, I want to verify it on my calculator. You have to graph, this is just how Texas Instruments works, the original function before you simplify it. And just to show you again, you had to do zoom, number 4, decimal. Now, of course, I want it back to the normal screen for whatever I'm going to do next, so I just hit my zoom 6. All right, so I just wanted to show you how to do that if you were curious. All right, so last thing I have to show you, of course, today that we have to go over is the slant asymptote. First off, let's talk about when do we have it. So it exists when the degree of the numerator, I can't write and talk, numerator is larger than the denominator. So we haven't seen this situation yet. Now, we've seen the situation where the degree of the top is smaller, like maybe x squared over x to the 4th. That is a horizontal. Y equals 0, there's no work. We've seen where the degrees are the same. X cubed over x cubed. Lead coefficients. Now we're going to talk about this. So what happens if the top, of course, is bigger? You no longer have a horizontal asymptote. It kicks it into a slant asymptote. So it is going to be a diagonal one this time. Now, a slant asymptote, and you're going to see on one of the graphs, you can touch a slant asymptote. You cannot touch a vertical or a horizontal, just to be clear. Now, here's the yuck part. How do we find the slant asymptote? So remember, we have these rational expressions, aka fractions. What does the fraction bar really mean for an operation? Divide. We have to divide these. I might get lucky and get to do synthetic. I'm probably going to have to do some long division today. So we're going to divide, and we want our answer in the form y equals mx plus b. Because we're looking for that slanted line. So you're going to see when I divide it, because I just want the mx plus b part, we're going to ignore the remainder. I don't want some fraction I have to try to deal with. That's how we're going to get our slant asymptote. So it's still easy. It's just kind of tedious depending on what style of division we have to do. Now, it's been a hot minute since we've done it. Remember, I really like synthetic better, I know. You can only use synthetic division if your divisor is a binomial, 2 terms, and your exponent is x to the first. Anything higher than x to the first, you have to do long division. So prepare yourselves. Let's take a look at this guy. So sketch the graph, blah, 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 all this stuff, yada, yada. Okay, so first off, I'm going to start it off just like we have been doing, meaning, so it's going to do it out of order. I'm going to do the vertical asymptote first. Easy peasy. I set my denominator to 0. It's nice. I don't really have to solve anything. I like it. Okay. I did take a quick glance at this guy. There is nothing to factor and cancel or anything, so I'm not worried about that. Let's get this marked, of course, x equals 0. Right there on the old y-axis. Okay, so next up, notice it doesn't say horizontal. It says slant. Now, you're going to have to know whether you have a slant or horizontal. Of course, you're going to look at these degrees. Squared, x to the first. Whenever the top is higher, it is a slant. Okay, so you got to first know that. Now, we're going to divide these out. Clearly, our divisor is a monomial, one term, we're over x. And plus, why not review long division when we have the opportunity? Let's divide it with long division. So I've got 2x squared plus 1 divided by x. So I'm just doing some very exciting long division here. Of course, to figure out what goes on top, x times what gives you 2x squared? We need a 2 and an x. We're, of course, going to subtract this, which switches the sign. I'm going to bring down the 1. Now, can you divide any more? No, 1's the remainder. Remember, I'm not putting plus 1 over x, okay, because we want our slant asymptote mx plus b style. No fractions in that, okay? So I'm just going to use the 2x at the top. So I'm going to write down on my slant asymptote y equals 2x. Now, I'm just going to mark that out like you would any boring diagonal line. Clearly, this is our slope. And for the sake of drama, I personally wouldn't write this. But, of course, our y-intercept is 0. All right, just mark out the line. You can do that. So y-intercept is 0, up 2 over 1. And I just put a lot of points on because, you know, I can't draw very great. Okay, draw your dashed line. And we got it. Now, I'm going to do the intercepts and all that stuff at the end. Let's try to get the curves drawn. Now, you are more than welcome to punch that in your calculator and get some points and do the T-chart and do all this stuff. I'm just going to quick do it by hand. Now, same thing as yesterday. If my vertical asymptote's at 0, I'm going to put numbers in on either side of it. So I'm going to put in -1 and 1. And you could get these off your T-chart on the calculator. Fine. I'm going to plug them in. If I put -1 in here for x and squared, I'm going to have 1 times 2 is 2, 2 plus 1, and I'm over -1. So I really have the point -1, -3. Now, these are going to look a little different, so to speak, than maybe some of our graphs yesterday. Because when I draw close to the vertical and close to the slant, it kind of, I don't want to say is a parabola, it's clearly not, but kind of looks like it, okay? So you're going to kind of have a little U-shaped sort of looking curve. Now, I'm guessing there's more up here. Obviously, I got to put 1 in. So I'm going to do some mental math, of course. 1 squared 1 times 2, 2 plus 1. So I have the point 1 comma 3, really. Now, same thing. I'm going to run close to my slant, close to the vertical. All right. Now, let's answer the intercepts. I like these. These are super easy. Because where does the purple curve hit the x-axis? Nowhere. That's my favorite. Where do the purple curves hit the y-axis? It doesn't. Winning. Now, just, you know, for the love of math, obviously, and remember, I made your quiz tomorrow. It's going to ask you on all of them to domain and range. I know it doesn't ask for everything on your notes and whatnot, but let's just do it just to practice. So I'm going to start off with the unknown number. Remember, domain is x, range is y. So, of course, I'm looking at my graph here, or you can look at your original function. If I don't even look at the picture, I'm just looking at my original function. I'm like, oh, what's the one number that's going to be problematic for me for x? 0. Because we have 0 in the line, undefined, we can't use it. Remember, that's our asymptote line, so that's going to be our issue. X can equal 0. Now, the range on this one, I'm not going to lie, it's a little trickier, okay? because I'm really going to write it in two inequalities. Here is why. So I'm looking at the purple, range everything up and down. So I have from this point below. Then I have from this point above. So I'm going to have to write two inequalities. One for this point and below. The y coordinate is at -3 right here. So I'm going to say y is less than or equal to -3. And then this one, our y coordinate right there on this point I'm looking at is 3. I'm above it. So I'm going to say also, of course, y is greater than or equal to 3. Okay. So that one's a little tricky because you have those two specific curves. All right, let's do one more. And of course, I don't care if you do the t-charts by hand or get them from your calculator. You don't have to write those, whatever. All right, last one. Here we go. I'm like, oh gosh, okay. First question. Can we do any sort of factoring and simplification? Is there something in common in all the terms? No, so I'm not going to worry about it. I know I could pull a 2 out of the bottom, but is there a 2 on the top to cancel? So what's the point? Okay, it's not going to get me anywhere. So I do check that. Obviously, no hole. I'm not going to factor and cancel. So again, you know, I like to do it out of order. I'm going to do vertical asymptotes first. So as always, I'm just going to set my bottom to 0. Now, I think I got to do a little bit of work here to solve this. So a couple choices. Of course, you could divide by 2. You could factor 2. We can add 8, divide by 2. I don't care. Let's just solve it. I'm going to add 8 over. I'm going to divide by 2. And then most of you probably have it from there. Super easy. Let's just root it. So get ready. What are your 2 asymptotes? Plus or minus 2? 2. We're getting fancy now. So this is one, I'm going to be honest, you might want to do the t-chart off of your graphing calculator. But hey, we're going to do it. Here we go. So 2, -2. This one I can already tell is going to be like a bad coloring accident happened here. Now, first off, obviously, it says slant asymptote on it. But again, you have to know on your quiz, oh, do I have a slant or a horizontal? You got to look at your degrees. Degree at the top is bigger. That is why it's a slant. Okay? So you got to know when you have what. And I'm like, oh, dear God, can I divide using synthetic? No, because our divisor has an x squared. So hey, we get to do long division again. Are you excited? Excited? So excited. Okay, so if I'm reading this fraction, I have x cubed divided by 2x squared minus 8. Okay, let's do the division. Here we go. Okay, hopefully we're good with fractions, my friend. For dramatic emphasis, I'm going to put a 1 right there. What times 2? Let's figure out the number part first. I know you need an x. What times 2 knocks it down to 1? Half, 0.5, yeah. And of course an x. That's as wild as the fraction calculation is going to be today. Okay, I think we can handle it. Half times 2, of course, 1, x and x. Half times -8, -4. Bless you. Of course, we're going to subtract, which switches our signs. And once again, do I even really care about the remainder? No, so I'm going to write it. Who cares? Okay, so I'm looking for this half x. So my slant asymptote is y equals 1/2 x. Now, we know M and B. We don't have to write out an M and B. Let's just mark it. Our y-intercept is 0. That's kind of common. Don't let that freak you out if you're getting that a lot. Slope a half. So 0. Okay. Pretend I do that straight, right? Now, I have to be honest with you. I don't know if this is one I really want to do a t-chart by hand and have to cube a number and do all that stuff. Plus, since you have 2 vertical asymptotes, we're going to have a part of the graph over here on the right. There's going to be a piece in the middle and a piece on the left. I can't really say that I want to do that all by hand. So, hey, let's practice typing in our calculator, shall we? So y equals, of course. Let me clear that out. Pull up your horizontal fraction bar. So I'm going to just type it in, just the original problem, just as it appears, x cubed. I hate this thing. I hit the right arrow. 2x squared minus 8. Okay, let's look at the graph first. Oh, okay. So remember, the calculator is not giving you the asymptote. So that's why I do those first. And look at, it's hitting 0, 0. Remember I said you can touch a slant. You can't touch a vertical or a horizontal. So I was like, okay, let's get some points off the t-shirt because this just looks bad. Oh, okay, that's fine. Okay, so first I'm going to start on the left-hand side here. I'm just going to work left to right. I'm going to use this point here on the left to -2. So, of course, we're going to have a little number sense. -27/10. You might be like, how in God's green am I going to graph that? Well, think about that as a decimal. That's about -2.7. I'm going to wing it and ballpark it. So I'm going to plot -3, -2.7. Oh, Lord. -3, -2.7. Let's do it in purple since I did the last one in purple. Okay, and I'm just going to look quick on the graph before I draw that part. So you can see you got the curve in there. Let's just kind of draw it. Okay, and again, my slant asymptote's not perfectly straight there. Let's look for some points in the middle. So pull up the calculator, back to the T-chart. So obviously -2, we have the 0. Error message, I mean. Okay, let's look in the middle. So now I'm looking between -2 and 2. I don't have a lot here. I'm going to put these on here. I'm going to ballpark it. -116. -116 is on there. 0 zeros on it. And then we have 1 -6. Okay. All right. So I'm going to take a little looky-loo here at this thing. Okay, so I got it. It's curving through. Okay, I'm just going to kind of draw that. Got it. Then I'm going to get a point over here on the right-hand side. So I'm just back to the table. This one's really kind of a pain to draw here. So I'm going to scroll past 2 because that was my asymptote. So same thing, 27/10 is 2.7. So I'm just going to wing that. So I'm going to graph 3, 2.7 best I can. 2.7. Same thing, close to the vertical. Whew. Ow. Yeah. Okay, that was a fun one to draw. Use your calculator to help you, just like I did. Now, intercepts, hey, I like it. It's going to be easy, I think. Where does it, purple curves, hit the x-axis? 0, 0. Right there at the origin. Where does it hit the y-axis? 0, 0. Now, again, I know it wasn't asked you on here, but I can't help myself. Let's do domain and range, of course, because that's going to be on the quiz tomorrow. Let's start with the boring stuff, okay? So, of course, X domain, I'm looking left to right here. So, in plus, really, I mean, this curve is going to keep going all the way to the left. This one's going to go all the way to the right. We've got this in the middle. There's only 2 numbers that are problematic for me for X. What are the 2 problem numbers for X? Positive and -2, where your asymptotes are. Because if you put 2 or -2 in here, you'll get 0 under the line. So X can equal with or -2. Got it. Okay, that was really riveting, I know. Okay, range. Let's look at the range. Now remember, we're looking at the range, all 3 of those purple pieces considered together. So I want to know lowest to highest. What do we cover? Well, that's going to keep going all the way down. This is going to go all the way down. That's going to go all the way up. This is going to go all the way up. Between all 3 pieces, we're going to cover everything. I mean, really, just doesn't the middle piece just alone cover it all? Lowest to highest? Yeah. So, I mean, I don't have to write anything else. I'm just going to leave it all real numbers. Got it. Okay. Any questions on that? Are they all that hard for the slants? No. But, you're going to do one kind of tricky one, right? Okay. So, I